database management system is concerned, we are going to see different set of activities or different set of topics, so which is based on database and views and models and architecture and introduction to relational database, as well as different keys and relationals. So what are the relational algebra which is going to inbuilt or which is going to take the flow of the particular data to different areas, all those things we will see, and the advanced SQL and the dynamic SQL. Okay, these are the concepts you are going to see. So first one, database. So what is the database? So it's a collection of real data. So collection of data in the sense we can use that data for a different set of related database. Related database, what is called a related database? How this relation is going to happen between one table and another table, and how the attributes are going to be exchanged based on this different set of entities which is going to be present in this particular database, right? So we have a specific type of data for storing, updating and reporting. So that is called as defining, constructing and manipulating. Okay, so these are the three definitions which is going to be inbuilt, and this one surely comes in the MCQ, just make it. Okay, right. Then the purpose. So what is the purpose? So purpose behind this one is redundancy, accessing data and multiple files, as well as atomicity of operation and the concurrent access with the multiple users and the security problems. Okay, so what are the security problems? What is the purpose of this particular database is, example, we have a different set of users. So these users are grouped and maintained as a data processing and handling. Okay, so they are having their own files for handling the data process, and different set of applications are used for handling this data process. So here we have a small example for how we can use this inconsistency or redundancy in a particular database. So a database example, in a university, a database is going to be handled based on a different personal registrations and accounting office, all those things. So this database has been grouped as a user, where the different set of registration codes will be handled and by a particular accounting office. So this accounting office, what they are going to do is, they are going to relate to the billing information. So how the students are coming, what are the different set of courses, what are the different course tracks which they are going to take, and based on the course tracks, what are the grades which is going to be awarded for each and every courses. All these things they are going to see by using different sort of storing the data, and the data will have multiple types. Okay, the same data will be stored in multiple times in a different storage. That is called as data redundancy. Okay, the data is stored in multiple times. That is called as a data redundancy. So by using this redundancy, we may face some different problems by using this redundancy. So we will check one by one what are the different issues we are going to face, and how the solution can be attained, all those things. Okay. Right. So now in the database there is a purpose. So what is the purpose behind this? Storage space. Storage space. So lot of storage space is needed for every database, and these database has to be stored in a multiple times. So there will be wastage. So if the same data is stored in multiple times, there will be a wastage. So in this case, we have a data inconsistency. What this inconsistency will do? So various copies of the same data will be taken and it will be accepted as a different set of database. Now, the same database example, date of birth is there. So for a date of birth, there is a format how the data has to be stored. Example, student date of birth. So now this student date of birth, whatever data you are giving, the same data is going to be entered correctly for a different users also. So based on this, if the same format is going to be typed, then only the particular database list will be executed. If not, it will not execute. So for this we have a different set of difficulties in accessing the data. So one is processing environment. So what is called a processing environment? So processing environment, we have a different set of needed data where we can retrieve the particular data for our convenience. Okay. So next, data isolation. So in data isolation, we are going to write new application programs. So we are going to write new application programs. So once we have written the new application, we are putting that particular query, and then we are going to retrieve the data using that particular new written application programs. Okay, but it's somewhat difficult also, data isolation. So what is next? Data integrity problem. So integrity, actually the database has to satisfy some types of consistency. Okay, so example, bank account. So bank account, bank account number cannot be changed again and again. So for this, we have additional appropriate code. So what are the different set of code and the various application programs? So that is atomicity problem. So what is called atomicity? So whatever the transaction is going to happen, entire or few is going to ensure that it have a conventional file system process. So this conventional file system process arrives only in the case of atomicity. Okay, so this example, from account A to B, if you are going to transact some amount, then that transfer amount is going to have a failure at some time. So when the failure will occur? The failure will occur only if the system crash or hard disk failure or power failure. So these are the three main three main problems that we might face while the system is going to corrupt or hang down. Okay, so in this case, if the transaction is going to be done from A to B of 50 rupees, while it's power failure means that transaction will be done but not be updated properly. In this case, if it's not updated means the result A will have a different result, and the resulting database state will be moved to a different position. Okay, so we have a current access automatically. So we have to see the overall performance, the fastness, responsibilities, the responsiveness, and multi-user activities or multiple users, how they are going to take part in this particular course of action, or how the interaction of the concurrent updation, all those things, and how far we are going to give the access and guard the particular access by a set of supervision. And there will be many difficult application program that may have a coordinated previously. What are the difficult set of application programs? When several reservation plus, example, in a reservation counter, you are going to reserve only airline reservation ticket. So how you are going to reserve it? Based on the time, date, time, place, and seat number, and the destination. So all these things has to be merged, and you have to check with the destination part of it, how it is going to taken care. So based on this, we have a different flight reservation system where we can have a set of activities, the different set of actions to be performed. For each and every seat, there will be a access to the particular clerk at a particular time for the particular destinations. Right now, so as of the application of a particular database is concerned, we have a different set of application called the banking, airlines, university, sales, manufacturing, human resource, and telecommunication, and also the credit card system for account transaction and the payments process. Okay, so these are the facilities or a different set of scenarios which will have dealt with the database applications. So there are few more scenarios also there, but mainly we are going to focus on the banking, airlines, university, sales, manufacturing, human resource, telecom, and credit cards. Okay, so using these, a set of scenario will be given, and you have to draw the ER diagram. Okay, get prepared for that one. So if it is a MCQ, they will ask a scenario, and they will give you 4 to 5 solutions. In that one, which solution is the feasible one, you have to pick or check. Okay. Right. Now, next step, view of data. So how the data is actually stored, and what are the different data structure, and how far this database is going to have, and the user, how the user is going to view these are in the case of two different views. One is data abstraction and instance and schema abstraction. One second. Okay, one is data abstraction and instance and schema data abstraction. Now, so what is called complex data structures? So here we are going to see the complex data structure using DBMS, which is going to hide some information which is not of use. So that hidden information which is not used or which is by which the user is not interested in seeing that one, that is called as data abstraction. So some DBMS is going to hide some information based on this, and we have to check with the different set of interest or traits where we have a complex form of picture where we can store abstract view of the database. So we have 3 levels in this particular abstraction. One is internal level, logical, and external. Okay, so while seeing internal, logical, and external, we have a data that is going to actually stored in database. So that is physical level. So physical level, how the lowest level, physical level is the lowest level of the abstraction where the data is going to store actually. Okay, so we have a path and index for the particular accessing file. So by using the particular path and the index, it's going to access a file from different locations. Okay, so next one, logical level. So what is the logical level? So there will be a strong relationship between one and another table structure where data can exchange and get the required data which is stored at a different places among those type of data. Right now, so view level. So view level is the interaction between database and the complexity remain unviewed. So it is called as chart and graph. So this view of data is in the form of chart and graph. So on this view 1, view 2 to view n, that is the view level and the logical level as well as physical level. So this is the chart of a particular view of data. Okay. Right. Before moving to the next topic, we will have one small slideshow. Okay, that is what is called DBMS. What are the key concepts in DBMS? Okay.
Hello friends, welcome back to Study Tonight's YouTube channel. In this video, we will talk about DBMS keys. Students are always confused about this concept as there are many different kinds of DBMS keys and almost all are related to each other with a slight difference, which makes it very difficult at times to get a clear understanding. In this video, we will learn what are database keys, why we need these, and the different types of the DBMS keys. A database key or a DBMS key is an attribute or a set of attributes which help you uniquely identify any record or row of data in a table. Let's take an example. In the table above, we have SID, SName, SBranch, and SEmail as attributes, saving details about students. If I ask you to tell me email address of the student with name Adam, can you tell me? No, because there are 2 students with name Adam. Or if I ask you tell me name of student who is in CS branch, again there will be many students in that branch. But if you look closely, SID column has unique value for all the rows of data, and the SEmail column also has unique email addresses. Hence, these 2 columns can be used to identify records in the above table. So we can say that SID and SEmail are keys for this relation. This brings us to the question, why we need keys. The first reason is pretty much obvious. Without a DBMS key, you cannot access the rows of data stored in the table uniquely. Because without a key, most of the time you will either receive multiple rows of data or incorrect rows of data. Another big reason, which is kind of an extension of the first reason, is we can force identity of data and ensure integrity of data is maintained using DBMS keys. By making an attribute key and making it mandatory, we can enforce that anything inserted in the table is identifiable, hence ensuring data integrity. And last but not the least, we can establish a relationship between tables using keys. It's time for the main event, types of DBMS keys. There are 8 different types of DBMS keys, of which super key is like the default key, and composite and compound keys are like cousin sisters. We'll see when we learn about them. So we will be starting with super key, then we will move on to candidate key, then primary and alternate keys, then the foreign key, which is different from all others and serves a purpose which none of the other keys do. And then we will cover the remaining keys, which are composite, compound, and surrogate. Super key is nothing but a key. It is a superset of keys in which all possible keys are included. Like in our example, SID, registration ID, email, then combination of them, SID, registration ID and email, email and SID, and then all 3 together, SID, registration ID, email, all are super keys. There can be more as well. In simpler words, an attribute or a set of attributes that can be used to identify records in a table is a super key. Then comes candidate key. It is the minimal set of super key which can be used to uniquely identify rows of data in a table. We saw that we have so many options for super keys, but most of them are formed by unnecessary pairing of keys, like email ID, SID, registration ID together as a key, or email SID as a key. When email SID and registration ID can individually uniquely identify a row of data. Hence, in this case, the 3 attributes SID, email, and registration ID of reg_id are the minimal set of super key, hence the candidate keys. Speaking in Book's language, if any proper subset of a super key is a super key, then that cannot be a candidate. Now let's try to understand this. Registration ID, email, and SID together form a super key, while email and SID is a proper subset of it and is also a super key. Hence, this is not a candidate. Similarly, email SID is a super key and its proper subset, email and SID, both can act as a super key individually. Hence, this is not a candidate. This way, we can come to a conclusive proof that SID, email, and registration ID are the candidate keys for the relationship that we have. Now, moving on to primary and alternate keys. A primary key is a candidate key which is used to uniquely identify every row of data in a table. Now, you must be thinking that we have 3 candidate keys and all of them can do so. Well, in that case, you can make anyone a primary key. This is generally done by database administrator to set a candidate key as a primary key. If we have to create a simple user interface to search for student information for our college using the table in the database that we have as an example, what will make more sense? SID, which is an auto-incremented value by the database itself, or registration ID, which every student knows and is more meaningful for college administration too. Hence, in this example, we can make reg_id or registration ID as primary key. All the remaining candidate keys which are not selected as a primary key are called alternate keys. Now, coming to foreign keys. Foreign key is nothing but an attribute in a table which is used to create a relationship of that table with some other table. In case our tables have relationship, using foreign keys helps us to maintain data integrity for the relationship. For this, we will have to involve another table in our example. Let's say we have one more table, branch, with information about the branches in the colleges. It has a unique column with branch code, branch name, HOD, and some more branch-related information. In the students table, the branch code can be made a foreign key to set up referential integrity or relationship between the table student and branch. This way, while making a new student entry, a wrong branch name cannot be provided, else a DB will return error. Similarly, if someone deletes a branch entry or updates a branch code in branch table, they will have to change the same in students table too. Generally, this is not allowed by the database, and the database returns error when someone tries to modify the column value which is used as a foreign key in some other table. Hence, this way we can force integrity of data in a relationship using foreign keys. Moving on to the remaining keys, a composite key has multiple attributes. Hence, all the super keys with more than one attribute are also composite. In our case, email SID together, SID registration ID together, registration ID email together, all are composite keys. If a composite key has one attribute, which is foreign key, then it is called a compound. Moving on to the surrogate key. Sometimes a relation or a table has no attribute which can uniquely identify the rows in the table. In this situation, when there is no natural primary key, we create an attribute to act as a primary key. That is a surrogate key. These keys do not add any meaning to the data, but serves the sole purpose of identifying the data. With this, we have covered all the DBMS keys, starting from super key, candidate key, and primary key, alternate key, foreign key, composite, and key.
We are seeing regarding that. Now we have a continuation of the view of database. So next one is data model. So what is called data model? So entire set of database structure. That is how it is going to describe the data design and how it is going to reflect the particular data. So we are going to check with that one. So the entire design of the data will be reflected on a particular entities, attributes, relationship, and other data with the constructs. So these are a set of logical structure which is going to be used in a particular data model. So in DBMS, we are going to use the data model with the set of the database design concepts, that is entities, attributes, relationship among data and constraints, and other set of type of design sensor we are going to enforce in this particular database. Okay. Right. So what are the different types of data models? So in a data model we have particular object, ER diagram and ER model. Okay. So ER model with the entity relationship model. So what is this ER model? The entity relationship model. So this is a way of describing how the particular business process is going to go from one end to another end for having a mapping between the different implemented database. The mapping in the sense the entire set of data entity set and the relationship set. How it's going to be interlinked using this components. So components in the sense that is ER models which is going to be inbuilt in this pattern. So ER model have a relational entity relational model. So it's a static way of describing how the particular business process is going to be defined. Okay. So now next we will see the data models in a particular object-oriented programming. How this object-oriented programming is going to be handled this particular class items. While seeing the particular procedures, we will have a different set of objects. So what is this object is? So object is nothing but there are a level of abstraction in this particular objects. So it includes attributes and the behaviors. So this a object has different levels. So both levels are described, that is attributes and behavior. So for a particular procedure with an object, it has a class hierarchy to be followed. So what are the class hierarchies? So record-based logical model. Record-based. So whatever the data is there, you have to describe the data with a conceptual use. One. Next, so we have to identify the fields and the attributes. So fields and attributes in the sense, so actually these model have a specific logic structure. So how this database is going to record, what are the from what it is going to record from which field, and what are the different set of attributes. All this. So we will have a different conceptual and different set of view levels which is going to be existed. Next up, relational model. So what's called a relational model? So while we are going to consider the relational, so we have to check that the set of group of columns and so we have to check with the group of columns and rows. What this group of columns and rows will do in a particular relational model, the data and the relationship, they are going to represent how the interrelated tables and how the collections of interrelated tables is going to be represented by the relationship, a different set of relationship using relational models. Okay. So here a different set of groups of columns and rows are there. So what they are going to do, they are going to represent that particular record. They are going to represent the particular record. Okay. So this will surely come in a MCQ. Just make a note. This will. So what this relation model is going to do? They are going to represent a particular set of records or a group from group of columns and the rows. Okay. So these records might be at a different set of entity, a different table, set of tables, where they are going to have a relation between the rows and columns and between the data for the particular record. Okay. So here we can have a simple statement called a student table, where a set of table is going to be have a 3 rows and 3 columns. Okay. So here just see a student will have a different set of attributes: student ID, student name, student address. All these are set of attributes for a particular student. So this student is going to study in a particular place. So where it is, it might be the college. So college will have college ID and the college name. Okay. So this is a simple ER diagram representation where a set of students going to study in a particular college. So for that set of students, there are different attributes. Where it's going to study, for that college, a set of attributes are there. So these are the simple ER diagram where sample ER diagram is shown for students, how they are going to, what type of student and which study, what type of course of study they are going to undertake from which college. Okay. Now in the diagram also you can see student ID, name and age, where a set of student IDs for 3 rows and 3 columns are given for student ID, name and age. Okay. Next, hierarchical model. So what are the different hierarchical models we are going to see? How we are going to organize? So there are hierarchical model is always, it is also called as it's like a tree structure, tree-like structure where it's going to build a different set of parent with their child and sub-childs, which is attached to that particular parent record. Okay, so there are many relationships between this parent and child also, one-to-one, one-to-many, many-to-one, and many-to-many relationship between the different nodes, which is going to have an interaction. And there are some drawbacks also while considering this parent-child linkage. So we'll see that one. Apart from that drawbacks, there are more advantages while considering this type of tree-like structure in a hierarchical model. Okay, so this is a tree-like structure where a different set of root, feet of child and the second child. So the first child will be from the first root. Example, this is the parent. Assume that root is the parent, and that is the employee is the parent where they have a compensation, job assignment, benefits. So these are the 3 things which are involved in a particular employee, and these 3 things are called as first child. These things are called as a first child, and from the compensation, rating and salary is extended. This is the second child where benefits, for the benefits, pension, insurance and health. Okay, so all pension, insurance, health, salary and the rating, all these things will come in the second child. So the root is the employee, from where we have first child, and from first child we are going to have the second child. So this is the tree-like structure in a hierarchical model. Okay. So while seeing the nodes also, we have a, suppose a particular person, we have a different set of root nodes. So from the root node, the student will have a student name, student ID and a student age. From there, which college or which course he is going to study, that is course ID and a course name. Okay, so this is a root node. From there a student is going to see, and from the student a particular type of course is going to be added. So here also root node, from the root node we have a particular student name and what type of course he is studying will know. Okay, so like the same way for different student, another student Chaitanya, we have student ID number and what type of courses. We might have taken 2 courses and study. So for that one also a sub child is added, that is 2 different courses. Okay, so this is simple hierarchical model diagram which is will be discussed. And next one is network model. So what is this network model? So network model, so it is also having the same graph-like structure. So rather than tree-based structure. Why this graph-based structure is implemented in this one? Because the hierarchy model tree structure might have some drawbacks, as I said earlier, but it can be overdone. So we have to see with the research the particular record which is going to take place in this particular network model. So we have more than one parent record. So each record have a different set of model and allow different hierarchical method in that one. So this graph-like structure rather than a tree-like structure. So it has a graph-like structure type of data. So in this one, we have a physical data model where it is going to describe the lowest level of abstraction. So already we have seen this one. A physical model will have a low-level abstraction. So here we have a full entire entity relationship data model, which is going to be shown. So there are a different set of attributes, example employee number, name, designation, salary, and the department number. So these are the attributes. So where the attributes have a different data values. Data values for each attribute is shown. So all the set of data values is called as entity. All the set of data values by attribute is called an entity. So all the values of the salary, salary is called domain of salary. All the values of department number is called domain of department number. So this is the entire set of the relationship is called entity set. Entire set is called entity set. So for example, we are going to write the year for a client database. We are going to check with the client. So what type of client is. So for a particular client, employee number, employee name, designation, salary, and the department number also included in the particular client. Why? Because they are going to deal with the that client only, and they are going to take the output from the client. Okay, right. Now we will stop the discussion here. Okay, the rest of them we will see in the next class. Okay, Harsha. Harsha, yeah. Can you send the attendance form? Okay. Okay, ma. Thanks for joining and take care. And be careful, ma. Nowadays, corona situation is going high for the second level. So don't move around here and there. Be safe in home itself and take hot water and other organic items which has been discussed and sent to your group also. Corona Kashayam. Okay. You used to take that one and be safe and be healthy. Okay. Okay. Thank you for joining.
Thank you, sir.
Thank you.